Have you ever tilted a gemstone ever so slightly and watched it answer with light? One breath of movement, and suddenly, it's alive. White brilliance, needle-thin flashes of red and blue. A shimmer that seems to pulse. It feels mystical, but it isn't. It's precision. Today, we're rewriting the story of sparkle. Light begins its journey in air, moving at astonishing speed. The moment it crosses into a gemstone, everything changes. The crystal is denser than air, so light slows down. And when light slows, it bends. That bending is refraction. Every transparent material has a refractive index, a number that describes how dramatically it redirects light. The higher the number, the stronger the bend. A refractive index around 1.5, like ordinary glass, produces modest sparkle, but a diamond with 2.42 bends light so aggressively that rays are driven inward. That's the first act, capture. Then comes confinement. Inside the gemstone are flat, polished surfaces called facets. They aren't decorative, they're strategic. When light traveling through the stone hits a facet at the right angle, it doesn't pass out into the air. It reflects completely back inside. This is total internal reflection. If the geometry is correct, light ricochets from facet to facet, staying trapped long enough to build intensity. When it finally escapes upward, it does so in a concentrated burst. That burst is brilliance, the return of white light to your eye. But geometry is unforgiving. Cut the stone to shallow and light leaks out the bottom. Cut it to deep and light spills from the sides. Only specific angles preserve the bounce. Sparkle isn't luck, it's engineering. Now we add complexity. White light is never truly white. It's a blend of wavelengths. When light bends entering a gemstone, each wavelength bends by a slightly different amount. Blue bends more. Red bends less. This separation is dispersion, when internally reflected light exits the stone after being split into colors. You see flashes of spectral fire, teeny fragments of rainbow breaking free. Some gemstones produce dramatic fire, others are subtler. The difference lies in how strongly they disperse. Light, different crystal structures, different optical behavior, different visual experience, same physics. But sparkle isn't constant. Move the stone, and light flickers. Some facets go dark, others ignite. This is scintillation, the dynamic pattern of bright and dark flashes created by motion. Your eye is incredibly sensitive to contrast. Bright, next to dark, feels alive. Constant brightness feels flat. Gray cutting balances three forces. Brilliance, white light return. Fire-colored flashes, scintillation, dynamic sparkle. Favor one, too much, and the others suffer. The most captivating stones choreograph all three. Look deeper into the crystal lattice itself. Gemstones are ordered atomic structures. Light travels through these repeating patterns predictably, but perfection is rare. Tiny internal features called inclusions interrupt the journey. They can scatter or absorb light. Too many, and brilliance fades. Yet sometimes imperfections create beauty. Silk-like structures can diffuse glow. Aligned inclusions can form stars. Clarity isn't about flawlessness, it's about preserving light pathways. Color plays its own role. Deep saturation means more absorption. If too much light is absorbed, less returns to the eye. A stone that is too dark may appear sleepy rather than vibrant. The most luminous gems balance richness with transparency. Because sparkle requires entry. No entry, no refraction. No refraction, no reflection. No reflection, no brilliance. Even the environment participates. Under sunlight, broad spectrum, and intense dispersion becomes dramatic. Under warm indoor light, reds and yellows dominate. Under cool eddies, blues sharpen. The stone doesn't change, the light does. Sparkle is a collaboration between crystal and environment. And here is the quiet truth. Gemstones do not create light. They choreograph it, they bend it, trap it, split it, release it. Every flash you see is light obeying geometry at microscopic precision. Even lab-grown crystals behave identically to their natural counterparts if their structure is the same. Physics doesn't recognize origin stories. It responds only to arrangement and angle. Structure determines behavior, always. So why does sparkle feel emotional? Because our brains are tuned to motion, contrast, and color shifts. Flicker triggers attention. Sudden brightness signals importance. Rapid flashes mimic fire and water, ancient visual cues of life and energy. A gemstone activates instincts older than language. It feels alive because it behaves dynamically. But beneath that sensation is something steady and measurable. Refraction, reflection, dispersion, geometry, the mathematics of light. The next time a gemstone erupts in brilliance as you turn your hand, pause. Inside that small crystal, photons are slowing, bending, colliding with boundaries at exact angles, splitting into wavelengths, and escaping in calculated bursts. Thousands of tiny optical events, perfectly lawful, perfectly predictable, and somehow still breathtaking. Because understanding the science doesn't drain the wonder, it deepens it. Sparkle is not the absence of explanation. It is the triumph of it. Light follows the rules, and when the rules are shaped beautifully enough, they look like magic.